This is part 1 of section 6.2, dealing with separable equations. So here's the first example. I want to find the general solution to this differential equation. You can notice we have x and y in our first derivative. So the technique of how to solve separable equations for AB covers basically you want to collect all the x terms along with the dx and get all the y terms along with the dy. And the key thing is you want to integrate both sides. Alright, so back to this problem. The first thing I want to do is rewrite this. Instead of y prime, I'm going to write this as dy dx. And it's going to be 2x all over y. So you can kind of think of this as a fraction. And what you want to do is get all the x terms with the dx. So I'm going to kind of think of this this dx and multiply it over. So when I multiply it over, I'm going to end up with 2x dx. And if I multiply this y term over, I'm going to end up with y and dy. Alright, so I'm kind of cross multiplying. Next step I wanted to do is you want to integrate both sides respectively. So this integral and this integral. So I'll write the step to integrate both sides. So the integral with respect to x over here is going to be 2x squared over 2 plus c. The integral on this side is going to be y squared over 2 plus c. I can simplify. I can reduce these 2's. So I end up with x squared plus c y squared over 2 plus c. Now you'll notice, since I integrated both sides, I have a c value on the left with the y term, a c value on the right with the x term. So since c is just an arbitrary constant, c is just some constant we haven't found yet, we're going to just have one c value. And because my derivative started with respect to x, that's what the side that gets the c value. Alright, so this integral doesn't get the c value. We're just going to have one c because it's just an arbitrary constant. So we're just going to say that the c goes on the side that the derivative was with respect to. And so that is our solution. It's going to be a y squared over 2 equal to x squared plus c. Now, something you might be thinking is, how much do I have to simplify my answer? Is this as far as I have to go? And the answer is, depends. So something I talked about last chapter was, well, how much you have to simplify really depends on what you need to do with the answer. So if it's to match something, like let's say on a multiple choice test, then you have to probably simplify this a little bit further. The back of the book probably simplifies this a little bit further. If it's simple, if you have to do additional stuff with this answer, you might need to simplify this. Something maybe you could do, since it's y squared over 2 and x squared, is if you subtract the x squared over, you would end up with y squared over 2 minus x squared equal to c. You might recognize this from pre-calc or maybe even algebra 2 as the form of a hyperbola. So in this case, maybe the answer would be left this way because it's the form of the way hyperbolas are written. So is this answer more correct than that answer? I would say no, it's equivalent. But again, depending on what you have to do with the answer, that'll kind of dictate, how much you would have to simplify. Alright, so we'll look at this slope field in class tomorrow, so we can kind of verify that this, in fact, is the answer. The hyperbola is what the form of the answer should be. Alright, so going over now, example 2. We have another differential equation, but this time we want it to pass through a certain point. So again, the technique is you want to cross multiply. You want to get dy in the y terms and the dx in the x terms. So I'm just going to rewrite this over here. Alright, so the first thing I want to do is get this x term and the dx on that side. So it would be turned into 1 over x squared y plus 3 dx and then dy. Alright, so I just multiply the dx on this side. And then I want to take this y plus 3 term and then multiply it over here on this side. Now, you don't have to highlight this if you don't like the way that it looks, or if you don't want to highlight it. You don't have to. I'm just kind of illustrating what's going where. So I have to multiply this entire y plus 3, because you can think of this y plus 3 as the whole y term. Alright. So now I have the x's and the dx's, I have the y's and the dy's. The next step would be to integrate both sides. So integrate this side over here, and integrate that side. Alright, when you go to integrate the 1 over y squared, or sorry, 1 over x squared, you can think of this as the integral of x to the negative 2. And this is going to require the power rule. So you add the power by 1, so it's going to be negative 1, all over negative 1 plus c, which simplifies to negative 1 over x plus c. The negative exponent drops it on the bottom, and you have a negative constant, so it's negative 1 over x. So this over here is negative 1 over x plus c. The integral of the left side, you do the power rule on each term. Antiderivative, or the integral of y to the first power, is y squared over 2. Antiderivative of 3 with respect to y is 3y. My initial derivative was with respect to x, so this side gets the plus c. Okay. So now we've done our integral. Now we want to apply the initial condition. We want to apply this point to find the c value. So the next step is to apply initial condition. So it's going to be a 2 and 1. Here's my x value, here's my y value. So plugging it in, it's going to give me 1 squared over 2 plus 3 times 1 equal to negative 1 over 2 plus c. 3 plus 1 half is going to give me 7 over 2. If I add the 1 half over, so 7 over 2 plus 1 over 2 equal to c. This is going to give me 8 over 2, which is the same thing as 4. So once you have the c value, it's going to be a particular solution. So basically, just take your general solution up here, and then the c value is 4, and that's going to be a particular solution. The particular solution just means that it's going to pass through the given point, the 2 and the 1. All right. Now, how much you simplify again depends on what you have to do with it. In this case, it doesn't really follow any particular form. There really isn't much you can do with this one. You can't really isolate y. It's not a common elliptical or anything. It's not a general generally known formula or function. So just, I would say, leave it like that. This would be your final answer. All right. There is one U-try problem. It isn't too difficult. It does require a u-sub on one of the integrals, so go ahead and I'll give this a try. You can pause it. And now I'll reveal the answer. So this is the solution. So what I did is I had to do a u-sub over here on the right side, the integral with respect to x on either the 2x required or u sub. You can kind of see what I did over here. And the integral of 4y to the third is just y to the fourth. Again, it doesn't follow any particular known function or anything like that, so you can probably just leave it like this, and this would be sufficient, this would be correct. And that's it for part 1 of section 6.2.